All right, these are mixed mole problems. Your test over moles will be mixed mole problems. So what are we going to need? We're going to need the mole chart, a periodic table, and what we know about chemical compounds to solve these problems. Okay, we need to show all our work, and let's box up our final answer so I can find it. Okay, so when we're doing these, we're going to have to figure out what do I know, what do I want to know, and then you can go back and look at the problems you've already done to figure out what you need to do. Okay, let's look, for example, on number 1. What is the mass of 3.4 moles of sodium sulfate? So what do I know here? That I've got 3.4 moles of sodium sulfate, and I want to know what is the mass of sodium sulfate. So that tells me I know moles, I want mass. So what do I know? I know moles, I want to know mass. So what am I going to do? I'm going to set up my train tracks. I'm going to write that up here. Moles to mass, or grams, because that's what we measure, moles to grams. And I'm going to set up my train tracks to go from moles to grams, okay? You know how to do moles to grams, and if you're not sure, let's go back a page. Moles to grams, just go to that heading and look and see what you did to solve those, okay? Same thing on number 2. How many moles of chlorine gas are in 4.92 liters of chlorine gas? So this time I know liters, and I want to know what? How many moles? So this says I'm going liters to moles. So once again, I'm going to look at what says right here. It says I'm going to put 1 mole on top, and I'm going to put 22.4 liters on the bottom. So I've got 1 mole of N2O, dinitrogen monoxide, and then I'm going to put 22.4 liters on the bottom. Okay, because I need liters to cancel, and I'll be left with moles, right? And you've done that calculation before, but here's where we're adding on. We're going to add a second train track, and we're going to take moles, because we're here, we're at Mr. Mole's house, and where are we going? We're going down here to particles. And what does it say on my arrow right there? It says I'm going to put 6.02 times 10 to the 23rd what? Particles. What are our particles here? Our particles are molecules of N2O over what? 1 mole. 1 mole of N2O. 1 mole N2O. Okay, because what happens? Moles of nitrogen, dinitrogen monoxide cancel out, and I'll be left with molecules. Okay, how do I calculate that? It's the same process you've been doing. Okay, so what are we going to do? We're going to multiply everything on the top, multiply everything on the bottom, and divide. But notice what cancels out. The 1's cancel out. So really all I need to do is multiply 79.4 times Avogadro's and divide by the bottom, which is 22.4. So let's do that. I'm going to put this in my calculator. Can everybody see my calculator? 79.4 times Avogadro 6.02. Again, the EE button, 23. Okay, so I've multiplied there. Enter. And I'm going to divide that by the bottom, which was 22.4. I'm going to hit Control Enter, and there's my answer. 2.13, again, round off to 2 places after your decimal, times 10 to the 24. So my answer is 2.13 times 10 to the 24th. What? Molecules. Can't spell. There is my answer. Okay, so let's look at it again. Multiply across the top, divide by the bottom. All right, it's not anything different than you've been doing. You know how to go liters to moles, right? And you know how to go from moles to molecules. We're just putting it all in one problem. All right, let's look at some more. All right, so I want you to try and figure out what kind of conversions 4 and 5 are. Number 6, though, is another multi-step one. 6, 8, 9, and 10 are going to take 2 train tracks to get there. So I want you to know that up front because you're going to do this on your test. All right. This one is, though, what do you know here? You know how many what? Silver atoms. You've got 5.83 times 10 to the 24th silver atoms. Okay, so I'm going to write that out in the start box. Times 10 to the 24th atoms. What kind of atom? Silver. Where's silver on my periodic table? He's number 47. Okay, so his symbol is Ag. Okay, what else do we know about silver? Well, he has a mass of 108 because we're going to need that. All right, so first conversion we want to make is we want to get, because we're over here at atoms, we want to get atoms to moles. So atoms to moles. It says I'm going to put 1 mole on the top and Avogadro's on the bottom. So that's exactly what I'm writing here. 1 mole on top, 1 mole over 6.02 times 10 to the 23rd what? Silver atoms. All right, so there's our first conversion, atoms to moles. But that doesn't answer my question because I want to know what is the mass. So this is atoms to mass, or I guess you'd say particles to grams, particles to grams. All right, so here we need to get from moles to mass, or moles to grams. So my next train track needs molar mass over 1 mole. Molar mass over 1 mole. Okay, so molar mass of what? Okay, 1 mole on the bottom. Molar mass. Well, it says silver. So that's where we're going to use the atomic weight of silver right here, that 108, because that's our mass of silver. We don't have silver chloride. We don't have a compound. We just have atoms. So all we need is the mass of that silver, right? Okay, let's look and see what we've got. Okay, atoms of silver will cancel. This 1 mole will cancel with this 1 mole. So what are we left with? We're left with 5.83 times 10 to the 24th times 108 divided by Avogadro's. That's how we're going to solve this to get grams of silver. Okay, so let's put this in our calculator. 5.83 EE to the 24th power times 108. Enter. And then we're going to divide that by Avogadro 6.02 EE23. Control Enter. And what do I get? It's a big number, I know. 1,045.91 grams. 1,045, not 45, not 95. 45.91 grams. Can you tell that's a 4? Grams of what? Silver. That is our answer there. Okay, multiply across the top, divide by the bottom. Okay, number 7's a 1-step, but again, 8, 9, and 10 are going to take 2 train tracks to get there. All right, I know you can figure it out. If you can't, let me know, and I will be happy to help you.